Welcome back, friends. Now that we have done with formation of partial differential equations, today we will see how to solve them. Let us say we have a linear partial differential equation in the form of pp plus qq equals to r. Okay, where this p we already know it is dou z by dou x, q is dou z by dou y. Okay, equal to r is some function of x comma y comma z. Such a form of a partial differential equation can be solved using a Lagrange's equation. So what is Lagrange's auxiliary equation? Let us say this particular one. It is just write dx by p equals to dy by q equals to z by r. Okay, and here this p q r. Okay, this is by mistake. Here it is only q. Okay, here p q r are coefficients here of small p of small q and this particular r. Now to solve a linear partial differential equation using Lagrange's method, we have few types. Let us say type 1. In type 1, we will directly see using an example. Okay, let us say we have a given partial differential equation as y square z by x into p plus xz into q equals to y square. To solve this, if we see this is in the form of p into p plus some q into q equals to r. Okay, so we can write Lagrange's auxiliary equation as dx by p dy by this particular q equals to r by this particular z, or we can say dz by this particular r. So once we get this auxiliary equation, let us say if we equate ratio 1 and ratio 2, here see, we get it as x dx by y square z equals to dy by xz. We will multiply x to this side, this z gets cancelled out, and y square to here. We get x square dx equals to y square dy. This is easily integrable. If we integrate on both sides, it will be x cube by 3. This will be y cube by 3 and some constant c1. So what do we get here? X cube minus y cube equal to c1. Yes, c1, it will be something c1 dash. Okay, because once you multiply with 3, here it will be 3c1. And this c1, I have just written as c1. Actually, it should have been c1 dash. I hope you understand this. Not a big change. Then, if we take ratio first and third, this and this, here y square will get cancelled out, and we are left with x dx equals to z dz. Okay, this one. And again, if we integrate on both sides, we'll get x square by 2 equals to z square by 2 plus some c2 dash. And once we multiply by 2, the constant 2c2 dash can be written as c2. Okay, not a big change, just a constant. So now we have solution in the form of c1 and c2, which we will write as phi of c. See, there are three methods to write a solution. Okay, first one is phi of c1 comma c2 equals to 0. Second is c1 equal to phi of c2. Okay, and or it can be c2 equals to phi of c1. So what I have written here is in the form of phi of c1 comma c2 equals to 0, where c1 is x minus x cube minus y cube and c2 is x square minus z square. Okay, this is the solution of our first problem to form a partial, sorry, to solve a partial differential equation, and it is of type 1. Okay, see you in the next question.